Okay, well, it's Wednesday. I swear to God, it's Wednesday. It really is Wednesday. And that means it's the state of energy today, the state of clean energy in Hawaii, because Hawaii, Wednesday, state of energy, synonymous, Okay, so here we are, Ray Starling and me, my co-host, talking about Hawaii, the state of clean energy on Wednesday. And in the center, between us, where we got him locked in, is Marc Matsuura from the university. In fact, he's the senior smart grid program manager. We're not kidding you. And he's associated with Hawaii Natural Energy Institute, and this is very important. This is going to be an important show.
Good. I hope so.
I'm telling you.
I'll take your word for it.
But in the
I
meantime,
hope I can deliver.
In the meantime, while Mark, is reeling from my comments, we have Carolyn Carl out there in the gallery, and Carolyn is ready to talk about the summer because the summer is upon us, and we need to know what to do in terms of energy efficiency for the summer. Ready, Carolyn?
I am. So you're right. It's hot. It's summertime. Everyone's out of school, which means that we tend to use a lot more energy in our homes and our electricity bill goes up. So Hawaii Energy is here to give you some low and no cost tips for saving energy. One of the first things that we recommend is using a ceiling fan instead of that room air conditioner. Energy Star ceiling fans actually use about 90% less electricity than a window air conditioner unit, and we have a rebate available. So if you go purchase an Energy Star ceiling fan, you can get $35 back.
That's pretty. What does an energy ceiling fan cost, though, in total?
There's quite a range depending on how fancy you want to get, and it often has a light fixture in it, but you can see them $70, $80, $90 up to $1,000.
Okay, but yeah. at least at the starter end, this would be a substantial contribution.
Yeah, 40% of the cost. Yeah, so it's great. And a lot of local retailers sell them. So some other tips to keep in mind are using advanced power strips. And I don't know if you're familiar with those or if you've got kids at home, but with the TV and the game consoles and all the entertainment stuff, oftentimes we switch off the television, but everything else stays on. So it's constantly drawing power, those phantom loads. Well, an advanced power strips allows you to control that and shut off the auxiliary equipment when you turn off the central television. So cuts those vampire loads, and you don't even have to do any extra work.
So this happens automatically?
Well, what happens is the strip itself it looks like a standard surge protector, but it has a control plug and then secondary plug. So whatever you plug into the control plug does essentially that. It acts as the controller for those secondary ones. So if you have the TV in there, you turn the TV off, the power is cut to those alternate plugs.
How does it know?
Because it knows once the power is cut to it. And then there's also...
It's like a thermos, I always ask, how does it know?
All right, and so our last tip for today is to remember to get rid of those incandescent light bulbs. Incandescent light bulbs are so much hotter than the energy efficient alternative, so we really encourage you to go to CFLs or even LEDs in order to not only cut the heat load, but also obviously save on a tremendous amount on your electricity.
Okay, so is there some incentive, specific incentive on the bulbs or on that special power strip?
The bulbs, absolutely. So at most of the local retailers, you can take advantage of our incentives. They're already built into the cost. So you're getting between $6 to $8 off on LEDs and at least $1 off on the CFLs. And for the advanced power strips, we don't have an incentive currently, but we are looking to incorporate that into our next program year. So definitely stay tuned and visit our website or give us a call, 537-5577.
Oh, what was that number again?
537-5577.
Did you get that, Ray?
I got it.
Okay.
Ray will answer.
Thank you, Carolyn. That
Thank
was excellent.
you.
What an excellent presentation. What do you think?
She's great.
Yeah.
She is.
Yeah. How about you, Mark?
I've
You
been
don't
looking-
know her
she's one
very
of our
well.
No,
What do you
secret
think?
assets.
But I've been looking for one of those outlet things, so I'll have to come talk to you, Caroline, later.
Wait, where do you get them, Carolyn? She's about to leave.
Sorry.
They're available at most local retailers, and you
okay.
can definitely find them online too. There's a lot of different varieties and flavors, but you can look at the details, and there's quite a few options. And they're usually priced anywhere between $25 to $40.
Okay.
Okay, good.
Thank you, Carolyn Carl. Most excellent.
Yay.
Thank you, Rod.
All right.
Okay, so now we're alone.
Now we're alone.
Should I be afraid?
No, your
Okay.
subject today
Yeah,
is central to what's going on out there.
Yeah, no, it's we live in interesting times. So
Well, let's
it's-
find
yeah.
out who you are, Mark. Who
Okay.
are you? I mean, where
Yeah.
you're at the. All I know is this: that you are the senior smart grid program manager. You're an engineer. You're also an MBA. Whoa, what a combination!
Yeah.
It's like schizophrenia, you know. and you're at HNEI at the East West
At the
Road
University
there.
of Hawaii.
Yeah. So, what a great position. How did you get there to that position?
Yeah, so it's senior smart grid program manager. It's easier to be senior because there's only one. That's me.
So you're also the junior.
Right, exactly. But I did have a career previous to this with Hawaiian Electric for 20 years, doing engineering, planning, operations a bit. But this position became available at the university, so it sounded like an opportunity to kind of take my experience and knowledge and kind of transfer it into the academic world to try to develop solutions. And it's part of our mission at HNEI, Hawaii Natural Energy Institute, is it was developed or originated in the 1970s when the first oil spike came. But so it's been in existence for a while, but like a lot of your shows point out, there's a lot of current near-term issues that are a bit different from the past decade. So
As a senior smart grid program manager, what do you work on?
yeah, so we develop, right now we have 3 smart grid projects that we're involved with on Maui. We're also involved with 3 battery energy storage projects, which you mentioned in your last show. We'll talk about that a little bit. So looking at the issues that we see the grid being faced with, and looking at kind of novel approaches, finding solutions. We also do studies on the renewable integration issues facing the grids, and come up with information that helps to inform lawmakers, policymakers.
Interconnect issues.
Interconnect, as well as total system integration issues.
Okay.
So if you take the grid from where it is now to much higher levels of penetration, what issues come up? What are
That's
what
really
are
important.
what are the different mitigation methods, which are the most effective, which are the most cost-effective mitigations?
Okay, so I have it straight. HNEI and the university's work in this is you're talking about doing technology, doing science, doing experiments, trying to get a handle on the way things might work if you implemented a given technology.
Right. So that's
It's
part
not,
of
you're
it.
not out there with a screwdriver installing stuff.
Not well for demonstration purposes.
Okay.
We do actually install equipment like batteries and inverters and things. The other thing that we do is on the policy side, look at policy issues. So John Cole, previous commissioner, is
Oh,
also
right, sure.
over at HNI working with us, and he's helping us with one of the integration studies that was similar to the kind of big wind study, the solar integration study. This is kind of another follow-on.
That's really an
study
important
that's going
study.
on.
What's
Yep.
the status? When are we going to see that?
It's ongoing, maybe latter part of this year or so.
Okay.
It's still in
Yeah,
progress.
I've got a simple question. You're going to smart grids now. That's sort of the new thing on the block. But why are we needing to go to that? What are the in layman's language? Could you explain for our audience out there what is it that's causing the need for a smarter grid?
Ask him also. I could slip in something here.
Okay.
What is a smart grid?
What is a smart
I was waiting for that question. Well, the good thing about being a smart grid program manager is the term smart grid is fairly broad, so you can kind of define it within a broad
Broad is a
parameter.
euphemism. It's actually vague as well.
Vague. Okay, vague. But maybe I'll start with the first question of why do we need it. So we talk about a paradigm shift of how things used to operate in the past with large central station generation, power flowing over to loads, loads being fairly predictable. And now as this renewable integration or renewables penetration start to rise on the grid, then that predictability of being able to dispatch generators to meet load and all of that has has changed in the past, I don't know, 5 or 6 years dramatically, right? So in order to deal with that paradigm shift of having generation that is not predictable, but also coming the other direction from the distribution grid, you need information control that is also distributed, and and being able to get information from what's going on out there so that you can control and monitor and make sure everything's operating properly and safely. So that's kind of the need. So what is it? There's a lot of things that are considered smart grid. You have people talk about microgrids, right? So there's that concept of having a smaller part of the grid that kind of operates on its own in a little island or connected island, and maybe island on its own. There's smart meters information from getting better information on loads and uses, but also providing more information to customers, providing pricing options for customers, so that we can incentivize usage and in a way that's most beneficial to the grid and shares costs in a way that is commensurate with people's usage. Right? So it provides for a lot more optionality in the services that can be provided and control that can be had on the grid.
Optionality. I like that one.
Yeah, not at the
Yeah.
What are some of the obstacles that you see out there for application of a smart grid? Is it just cost, or are there other barriers that make it not happen as quickly as you would like to see?
Yeah. Well, one thing is the technology is maturing, right? So I think it's getting to the point where people have had several years of experience with things like smart meters and data analytics and how to use all that data that's coming back from those meters and other sensors on the grid. So there were some growing pains in that area in the first implementations. So I think those have kind of worked themselves out. So that's kind of one concern, is the maturity of the technology, because you're going to spend a lot of money on it, and you want to make sure it's something that will last for a while. The other thing is standards, having interoperability. So you want to deploy a system that then you can add on to in a way that it all works together. So that was another big effort in the past few years of trying to ensure standards are in place so that this interoperability of equipment is also in place. And then there's also the cost issue, right? Of how much is it going to cost? How much is it going to save? What's that cost benefit trade-off? Who's going to pay for it? All those questions. So it's a fairly complex issue.
Yeah, but
so,
you know what we're not hearing? I mean, unless maybe I'm having hearing problems. Maybe I am having hearing problems.
Maybe I'm speaking problems. But go ahead.
What exactly are we talking about in terms of the gizmos and devices? I mean, is there a room somewhere with steel shelves with a whole bunch of little devices, and you walk in and say, oh, Fidell's house. Well, he'll have SJ67, SJ69, and 321. Put them on Fidell's house. And I, get them on my house. Or is that still way off? I mean, are there specific devices that are being deployed, make it this way, have been actually deployed, so we can say that at some level, yes, Jay, yes, Ray, there is a smart grid. Yes, you've been wondering, now you know.
Yeah.
What do you think?
I think there's certainly components that have been deployed, like we talked about. Advanced smart meter is probably the most widely deployed component of smart grids, right?
3 of them. Three
meters.
How many?
Oh, in the nation?
No. Oh, wait, we're talking different.
Yeah.
This is good.
Okay.
So, in the state of Hawaii,
Right.
how many smart meters are out there plugged in on somebody's house? I can tell you there's none on my house, and I feel certain there's none on Ray's house either.
I don't have one on mine either.
Okay.
So Kauai, island of Kauai, fully deployed for all their most of their customers, I would say.
They have a small customer base, though. And it's,
Right, but it still was the first tranche for Hawaii as far as the full deployment.
Sure.
And people didn't want it.
Right.
That was the amazing thing. I felt like
going
going out there with a bat, on the side of the head.
And
they actually voted against it.
And it's even today at conferences I go to, it's brought up as an example of the potential customer backlash, so that you need to be cognizant and careful to in your deployment, that you educate people and make them understand what
Irrationality. I just don't. There's no good reason in the world in the 21st century to say no to that. Are they worried that somebody's going to know that they're actually turning on a light switch? Ooh, that's pretty confidential information.
Yeah. There's issues that you have to communicate to people. What kind of information you're going to gather, what you're going to do with
You're
it,
very kind.
who owns it, right? So, so there are issues that need to be communicated.
Yeah. Can 30,000 people be wrong? Yes.
So, yeah. Well, but to get to your other point, that in Hawaii, that's kind of the biggest deployment. So there's tens of thousands of customers that Hawaii has. I'm not sure what their customer count is. But then the only other place that I know of is in our smart grid projects. So we have a neighborhood on Maui that we've deployed out of 800 customers on a circuit, I think it's about 80
smart grid. This is part of the Hitachi program?
No, it's actually the first smart grid project was a DOE funded project.
Is Hitachi active on Maui?
Yes.
So did it come into this as an after the fact thing?
There's 3 projects ongoing on Maui right now, and they're 2 of them that are DOE funded are in the same location, and the Hitachi project is right next door.
Okay, it's just all about smart meters or something else?
Nope. There's the first project was a smart meter deployment, and it was an opt-in. If you wanted one, you could get it. But with it came a portal where you could see your usage. You got a lot more information on what's going on. There was energy audit that was done for customers, looking at the data. And we actually found one customer where his solar water heater wasn't quite working properly, so it was using energy at night when he didn't think it should be, and he was right. So they corrected that, and he's actually saving energy because he had that.
But this is all sort of experimental. It's a demo. We're trying this out.
The smart meter portion is not so. That's kind of a more mature technology, right? So we partnered with Silver Springs, the same one that HECO is currently partnering with. But we also then added a load control aspect of it, where we could use the metering communications to then activate load control on the circuit.
Who makes this thing?
I believe it was a company called
Drill down on this,
I believe it was an Intergate device. So it's a device that was intended to kind of monitor what load is available and try to give information to the operators of what kind of load control is.
So it sort of emulates a load.
Well, it monitors the load. Like, say a water heater is under load control, and if an issue happens on the grid, they say, I need to trip some water heaters to reduce the load. So the operator has not only control, but some visibility of.
This is the device they talk about. I mean, so if your house is, if my circuit is using too much, then I have an arrangement with the utility that they can turn off something in my house, a given appliance.
And Hawaiian Electric has the water heater program with 38,000.
38,000 people have agreed to this.
Right, on their water heaters.
And right now, the utility can turn off the. And does it? It actually turns it off?
I have one in my house, and sometimes I come home and there's a little red light saying it's off, and it's off not more than an hour usually. So I didn't even.
Working.
I don't notice it. I still have hot water in my water heater.
Where's the little red light?
It's on a switch. There's a little box above your water heater.
You happen to be really sensitive to that because you're a scientist.
Well, so I'm interested. Did they use it today? Right?
Right.
Most people don't even notice. Yeah.
So that 38,000 people, that's pretty good, actually. There's something happening there.
So that's another big part of what they call smart grid, is having demand response either through pricing or actual direct control, right, of load, so that the operators have another resource other than the generation to help to balance that generation load balance.
Okay, one other thing, can we get into the disconnect? I mean, the interconnect.
Oh, okay.
It's about the same.
Right.
It's just going in the other direction.
So I have a $200 box. It's a black box, okay? And it has a little tag, so do not open this box under penalty of law. Just like my pillowcases, it's the same thing.
Okay.
And this box, is connected to the utility by way of the internet, high speed. And when the utility has enough already, when my circuit is over, it shuts down my photovoltaic array, and now I get no juice flowing back to the utility by way of net energy metering.
You would be unique if you had
Is
such
this
a
a
box.
hypothetical, or you really have one?
You let me finish my question,
I mean,
then you can tell if it's
Okay.
hypothetical. Okay, and what happens is, I get paid wholesale, not retail, for the hours where the utility can take it, and I get nothing. Okay, when the utility can't take it, it's grounded or something. It goes away. But if I get one of those Empower systems, storage in my backyard kind of system, personal storage, then I can always store it there. I can direct it there. So I get the best of both worlds. Okay, so my first question is, does anybody in the state have this?
Not what you described.
What do they have?
Well, that leads us to the second DOE project, which is a smart inverter project. So there, instead of using...
What's an inverter? Tell
Oh,
the
I'm
man
sorry.
what's an inverter.
So there's panels on your roof. It creates DC voltage and current, so DC power. The inverter takes that DC power and converts it into a 60 hertz or whatever the frequency of the grid is, AC power that can feed into the grid.
Yeah. So it's
It's a
compatible
converter.
with what I have in my house, what I need for
Right,
my house.
right. It creates an AC power
So
supply
trying
that
to
you
do
can...
DC to my refrigerator is not going to work.
Not yet. There are people that are looking at that concept of going from avoiding. There are losses as you convert from DC to AC.
So if I'm off the grid, if I go bare, sorry, that's what they
You
say.
might want to go DC as well.
And then I might want to have my whole house
So
DC.
the people are thinking about that was all our computers, our screen, monitors. They're all basically DC internally, but there's a conversion that goes again from AC back to DC to use it.
Yeah.
So there are DC.
Sounds like a long way to
devices.
go when everything around
Oh
you
yeah,
is AC.
yeah. People are working on it. It's not
Long
available or
job.
cost effective yet.
Okay, so you were saying they have.
So what the project that we're doing, we're partnering with a company called Fronius out of Germany and then Hitachi, who have smart inverters that have smart capabilities such as, like you talked about, being able to curtail the output if you need to. It can adjust it can do voltage control basically by adjusting what they call reactive power.
Yeah.
And you can also do real power modulation based on voltage as well. So there's different capabilities, and we're again utilizing the smart meter communications infrastructure to communicate from the utility over to the inverters to send the commands of what the utility wants it to do.
So what's missing? Why don't we have that?
There's technologies that have to be developed
What?
to make that work.
What?
So the interface between the AMI is the automatic metering infrastructure. So AMI communications is mesh communication that's available, and then there's a communications board in the inverter, but you have to create an interface, a communications protocol interface that converts it to the language that the inverter wants to speak. So that was part of it. The other part that was developed was the control software. So there was software that you could use to group inverters on the grid and send just that group certain commands and another group another command, but software that you could use to schedule and send commands to the inverters.
Okay, so you've identified some areas where the computer science department up at UH Manoa could really be helpful. Why don't they just do that? They become millionaires overnight. Get a patent.
Yeah, so-
we're off and running. What do you think? It's that dream of a tech industry in Hawaii come
That's
true.
right.
That's right. Yeah. So there's definitely a lot of room for development of these types of technologies. Again, getting it to a point where it's scalable and commercially available is then the next step once the research is done. But that's only part of it, right? So the technology piece is one, but you kind of touched upon it in your last show, is the policy needs to again then follow or even preclude the technology
What policy
advancement.
exactly?
So, like you said, if connect to the grid, the utility shall have the ability to curtail my output or cut off my output if it sees fit, right? So that tariff or ability for the utility to do that to somebody's PV needs to be developed.
It's an algorithm, and it's on a chip the size of my pinky nail. Okay?
Well, the contractual agreement that allows
Oh.
the utility to do that.
Okay, so
Right.
but if you have that, the only question is what the algorithm is. It says this circuit is overloaded. Now, what does overloaded means? Definitional. So I said, well, this circuit is more than watts and ohms and whatever volts, and that defines overload. And so we all agree here, okay, that circuit would be overloaded, and it should shut off, curtail the power from that particular person, and it's all by an Ethernet cable, to the inverter or whatever equipment is there, and it comes by way of a machine that sends a signal from the utility, because the utility knows the larger picture, okay, and and we agree, a scientist and an efficiency person, and just a general kibitzer, we agree that this algorithm works this way. We can put it down in a little formula about that big on my thumbnail, okay? And if someone else, like the legislature or the PUC or the energy office in state government, if they feel the algorithm is wrong, that it's not taking enough power, we use their algorithm, okay? And if it fails, it's their fault. It's that simple. And the public will be mad as hornets if it fails. And then they'll have political accountability.
I like your thinking. You're very astute, and in fact, there is such a model, but in what I would term maybe smart grid, but at the transmission level. Again, on Maui, there are 3 wind farms, and they all are in a curtailment order, right? So the last one on is the first to be curtailed. The last one that was built, basically.
Can't you curtail all of them at the same time?
You can, but there's an order. Like when the load comes down and there's not enough load for it to serve using the wind, then they have to back the wind down after they've backed down all their conventional generation to the minimum.
But from an engineering point of view, this is really interesting. Because the Maui, we know how hot it is on Maui about curtailment. I mean, it created that really punitive order last summer, the summer before. Well, it was only last summer. An $8 million fine, remember that? Ooh.
So they developed a curtailment reduction plan.
But are you saying, as an engineering matter, that you could curtail all of the windmills, in an even degree, instead of going down a sequence of this wind farm, then that one?
Nope. That's a little different from my point. Is you need to? There are contractual arrangements already between the wind farms.
Engineering-wise.
Well, you can. Yeah, you can definitely technically curtail them all pro rata.
So why don't we do that?
Right.
Isn't that more fair?
Why
do we have to go on seniority or clout?
Because that's the way the 3 contracts are written.
Okay, well, let's leave that one there.
But they have a smart system in their control room that looks at once all the units are back down to their minimum, and they have to start curtailing wind, that it'll in order go curtail the first one, then the next one. But the problem is if the first one, goes, or the second one goes down, this one can come up. So you kind of have to. If a human was sitting there, you'd have to kind of this guy up, this guy down. Oh, now he can
automate all of
so
that.
now it's all automated. So every 4 seconds it recalculates and dispatches the wind.
Are you working on that, or is
that's done. So
it's already done. It's in effect. It doesn't need any further work.
It's already in operation.
So now you have in front of you this chart, which shows energy storage projects.
Yes, so I know
which comes as a wonderful delight to Ray and me, because we find that there are actual storage facilities happening in the state. Can you give our listeners, and this is almost wonderful, worth waiting for, where are they?
Okay. I noticed in your last segment that you had mentioned storage, so I brought a little graphic here.
Okay, that's good. That's good.
Zoom
that's
in
about
on
as good
it,
as
but
it's gonna
that's about
get.
it gets. Okay. So there's quite a few installations in the state. Kind of the larger ones, I would say, would be on Maui. Again, the last wind farm that went in had a 10 megawatt, 20 megawatt hour battery that went in with it. and that was financed by the wind farm, and it allowed them
At
to.
the utility's request. I mean,
Well, it was
it's part of the purchase power agreement, right?
correct, but the need for the battery system and the way the battery was programmed to operate was developed jointly between the utility and the wind farm. And by the wind farm putting the battery in, it allowed the utility to operate differently in a way that allowed the wind farm to basically double its
Less
output.
curtailment.
Less curtailment,
Yeah,
correct.
yeah.
So it made financial
It's a
sense.
win-win-win, yeah.
Yeah, for them to buy it and put it in.
So, but the wind farm is the one who footed the bill.
Correct. Yep.
Okay.
So that's one. There's another one on another wind farm on Maui that was put in for ramp rate control. Is again part of the PPA as a connection requirement. Kauai has quite a few batteries and it's quite sizable for the size of their grid. That's helping them to regulate the large amount of PV that they put on their grid. So there's, I think, 3 battery systems on Kauai, and then there's some smaller ones on Oahu. On Lanai, there's I forget the size of it, but there's a battery there that went in with the 1.2 megawatt PV system, and that's helping it to manage the ramp rate of those.
Oh,
PV
yeah,
farms.
sure. That's an extreme battery.
Correct. Yep.
I remember
Yep.
seeing them install that.
Yeah, most of these, well, the ones on Kauai, the Lanai one are extreme power batteries.
Yeah. Extreme is the same one that had the fire, though.
Correct. Yeah.
So,
Yeah. So that's
how confident are we then?
well, we're hopeful. Like I said, again, like you talked about with the maturity of the technology, there's a lot of battery technology development going on right now. So that's part of what we're trying to do at the university is to look at these different technologies, and the projects that I have highlighted in red here are the ones that the university is involved with and is financing through
So
grants.
there's 3-4 of them.
I'm sorry, 3. Well, this is saying HNEI
Oh,
projects.
okay, 3 of them anyway, out
Yeah,
of
so-
about
so-
a dozen or so.
Right. So there's one on the Big Island that's already in. It's a 1 megawatt, 250 kilowatt hour battery. And then there's one that's going to go in soon on Oahu, about 1 megawatt, same size. We're looking at one for Molokai, which is 2 megawatts and 300 kilowatt hours, because Molokai has a load of maybe 3 or 4 megawatts during the day, and they have over a megawatt of PV on that system, and that system's frequency is very dynamic compared to the others.
They're in a process, aren't they? Now they were entertaining some other deal. Anyway, I wanted to ask you one other thing. All of these on the chart, which you call energy storage projects, including the ones you're working on and all the others, are merely to smooth the load. They are not going to last, like for
Right.
an extended period of time.
Correct. Yes. So that part of one example, like the big one on Maui with the wind farm, part of that study showed that it was more economically advantageous to have the battery help as a reserve resource, so that the utility could avoid starting units for reserves and taking room on the grid, rather than taking that energy and shifting it to another time of day.
Now, these storage facilities affect wind and photovoltaic, or just wind?
That's another point of research. Is initially the batteries, like the Kuku wind farm one and the Lanai battery, were put in to help smooth the output of that resource. The conventional wisdom is it's technically better to manage frequency rather than ramp rates of the individual facilities. Because, for example, if you're in
You can use software to manage the ramp rate if you can.
yeah, but if the ramp rate of the facility is affecting your frequency. So at the end of the day, you're trying to keep frequency stable. So instead of managing ramp rate, why not just manage
So
frequency?
it has to be between, what is it, 59.5 and 60.5
He's pretty
cycles per second
For PV, you mean? Well,
for any of it.
No, the
well,
system. The system.
yeah, well, the system is targeted for 60 hertz, right? So
See, Ray and I, we learned stuff.
right. So that's one issue for Molokai is that what I mentioned PV is the PV is initially was programmed to go offline at 59.3 on an under frequency, but Hawaii widened it to 57 hertz. But even on Molokai, when you have a generator trip or fault, it goes below 57.
Okay,
so
well,
you're gonna
here's the
lose all
thing,
that.
and we can, give you a little time to think about your answer. But, we're looking to HNEI, Mark, and that means you, okay, to do some brilliant work and find a battery storage technology that will distinguish our state and make us, able to use PV overnight.
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 Oh, okay.
That means you can save it during the peak hours, or the
I
peak
see.
PV hours, and
Okay.
use it when the sun
Sun's
don't
not shining.
shine.
I thought you meant have a solution overnight. So, but
That wouldn't
That
be
too.
that wouldn't be soon enough. But okay, we're going to take a short break, and then first of all, we're going to get Ray in there for some redirect and recross,
Okay.
and and then we're going to ask you that question.
Good.
Okay, that's Marc Matsuura. He's a senior Smart Grid Program Manager at HNEI,
and junior too.
and junior, and medium.
So,
You need help.
I do.
This is Hawaii, the state of clean energy. That's Ray Starling down the end. I'm Jay Fidell, and we'll be right back.
Hello, I'm Martin Despang, and I'm the host together with the one and only Ali Yamashita, and our show is called Urban Transcendence. And Urban Transcendence is about identifying where we have a unique situation of a vibrant city in one of the most beautiful natural environments. So how these two can coincide, sometimes conflict, how they could find reciprocity in the 21st century is what we're excited about. And we're planning on bringing in a diverse body of guests, both from the arts and the science and the established and the wise and the emerging generation. So hope you will join us. We'll always be on Thursdays from 1 to 2 p.m.
And here we are, we're back, we're live here on a Wednesday in Hawaii, the state of clean energy. We're talking with Marc Matsuura, who's a senior smart grid program manager at HNEI. And no pressure, Marc, but we're looking to you to make us a smart grid and to make that smart grid work all the time on renewables only. Okay. So first, Ray, what kind of redirect and recross have you been thinking
Well, I
of?
wanted to ask. When I looked at your chart, I realized that it was all about battery power, battery backup storage. And I was wondering, what is sort of the next technology that might be used? And have you been looking, has HNI looked at all at the other technologies that are out there? I know everybody seems to be interested in batteries, but is that just because there's nothing else worth having?
In regards to
In regards
storage?
to storage that would allow more
I see.
PV
I see.
penetration.
So
That's the big question.
there's there are different kinds of storage, I think, which is what you're alluding to. Is thermal storage, there's battery storage, there's compressed air storage, so all kinds of different storage. So there have been studies on, I think, pumped hydro is one, right? One thing that people talk about a lot. So there are definitely benefits, and that is more of a storage type that's more suited for the large energy, kind of shifting type of technology. But again, the cost of that is high, so
Right.
that you need to demonstrate enough benefit out of that shifting technology to pay for that. So pretty much, I think battery storage right now is kind of the focus of where we see, I think, things happening. And like you mentioned, as far as helping PV systems, having some kind of storage, whether it be like water heaters, which is a thermal type of storage, or batteries, those are kind of the two pieces that I think is more feasible to be implemented at the user level.
Let me ask another related question then. If you're looking at batteries, what would you need to do with a battery in terms of length of time? I know there's different lengths of time that the battery can run at its full capacity, or disgorge all of its saved kilowatt hours, right? What is the time that you really need from an operational point of view to make that big enough to solve your problem? You mentioned ramp rate, and I'm wondering what is the period of time? Are we talking about 5 minutes? Are we talking about 20 minutes? 30 minutes? How long would the battery have to help you through a dip in order for you to get your fossil units restarted?
Right. Okay.
Yeah.
Good.
Is that?
No, fair. That's a very good question. So you're right. I mean, there are issues in multiple time frames. Be less than a second. Seconds, minutes, hours, in the operation of a grid. So if you talk about ramp rates, those are normally measured in minutes, so megawatts per minute. But then there is a possibility of multiple minutes lining up where you have a sustained ramp, which then lasts for tens of minutes, that the grid would have to again handle. So it's a bit complicated, but maybe by example I can again, in the Maui situation where the battery was fairly lengthy, year study was done. It was determined that the Maui system has about 12.5 megawatts of quick start units that they can, kind of fire up in a few minutes time frame. So that's kind of counted as reserves. But then the next tranche of reserves was maybe about an hour time frame. Maybe 45 minutes to get on the grid and another 45 to get it fully capable. So in that study, it was determined that a battery size that would allow for 45 minutes of full output.
That's a big battery.
And then another 45 minutes of ramp down output. That would allow the utility to avoid starting those next layer big units, because they could wait and see. And if they did see a big event, the battery would take care of it until they got the next unit on. So they didn't have to start it in advance of an event happening.
Okay,
Right?
good.
So that, like you said, that's a big chunk of storage. So it's in that case, it's 20 megawatt hours of storage. So it's sizable.
Yeah. What does a battery like that cost? It must be expensive, millions, eh?
I would say, that again, the wind farm bought it, so that kind of information was proprietary, but it is in the millions.
But say a 20 megawatt hour,
Yep,
20 megawatt hour. So if you've got a 20-minute ramp, that's basically you have to deal with 1 megawatt per minute. Would that be? For every minute, you have to be able to sustain a battery of 1 megawatt, right? So what I'm getting at is, from the conservation and efficiency point of view, could you just, let's say you had the ability to shut off 1 megawatt of usage somewhere that wouldn't disturb anybody. Maybe shut off one of Jay's many lights.
These are all LED.
No, your older lights. I remember the ones that were.
Okay. I see where you're going.
So what I'm really trying to understand, it would be only 1 megawatt, right? If you shut it off and kept it off, it'd be 1 megawatt for ever how long you wanted it. And if it was, 20 megawatt hours, you could.
Right. So like, for example, if you wanted a load management resource that's comparable to the 10 megawatt, 20 megawatt hour battery, right? You would need a resource that you could reliably count on any time of day.
Right.
That if you acted on it, it would give you at least 10 megawatts, and it would keep that 10 megawatts off for 45 minutes.
So it would first of all have to be something that is running all the time, right?
Or in aggregate, statistically, the minimum you're going to get is 10 megawatts.
Gotcha.
Right.
Gotcha.
Right. So that's the difference between load management and batteries. Is if you know the state of charge of the battery, you know what you can get if you press the button.
Right.
Right. Whereas the load is a little more statistical in nature. You're not.
But
quite sure what
if you've targeted like
but there
4
is,
or 5 systems and you're monitoring them, you know how much they're using collectively.
Yep.
And you can pull the trigger and shut them down. Yep. So that could be an alternative.
Right. Right.
Or
Thank you.
or not an alternative, but rather something to play in the game, so to speak.
Right. So thank you for the segue to the next
Okay, and I didn't
Hitachi
plan
project. But this is, again, I may be hard to see, but we talked about the DOE project, and this is kind of a picture of that project where there is a battery in there, there's AMI, there's some load control. Then there's the Japan Hawaii partnership that Hitachi is the technology provider for that. But in that project, there is a local controller, they call it micro DMS, that's monitoring the loads and the voltages and the potential overloads of the transformer and controlling loads, like you said, monitoring loads, like what's there, what do I have to control, and then using that locally if it's needed. But then also that microcontroller is communicating back to the central controller, and if it doesn't need to do anything, because everything's fine, but I still have all these resources, I communicate that back to the central office saying, I got these resources that if you need them for a system level issue, like a big wind ramp or something, that you can use it. Right.
This isn't perfected yet.
Oh no, this is cutting edge stuff.
So and Hitachi is actively involved in making this gear.
They've developed the technology for this project.
Why not you?
I don't have quite the resources.
Does the university have the resources? I mean, in School of Engineering, for example. Why don't we take the bull by the horns here and make a smart grid? I mean, that's too bold to put it that way, but why don't we just do it?
There's the technology aspect, like we talked about, and then the.
I mean, you've been talking with Ray about switching equipment, about smart switching equipment, which says, here are it's like one of those computer games. Here are my inventory and my resources, okay, and I want to deploy them, so I make some processing and figure out where they're needed, and then I automatically send my resources to where they're needed. It's not rocket science. It's not.
Yeah.
Why can't we do that?
Yes, I think the technology is there to do some things you want to do. The next then layer is, I think, well, from my understanding, what HECO's doing now is kind of a demonstration, first deployment of a smart grid system on Oahu. But so because the issue that regulators, consumer advocate, all those people that worry about who's going to pay for it, right? They want to see
that's another issue.
What is it
going
What is it going to cost, and then but what are the benefits? So I think one of the objectives of this initial deployment is to vet out what are the benefits, and see how that works out. So there's things that are being done that they're going to try out, like there's concepts, they call it conservation voltage reduction, I think is one of the big things. Conservation voltage reduction. So there's a CVR factor, they call it, that says if you reduce the voltage by 1%, you generally can reduce the consumption around 0.8%. So there's, your lights shine a little less brightly, and for resistive loads, there's other like excitation currents and things that get reduced. But so a lot of technical things happen, but basically you reduce your consumption.
We've been doing this for as long as the Clean Energy Initiative has existed. We were talking about smart grids back in, I know it seems like a long time, 2008, that's only 6 years, but in energy development, it's a long time. And in public expectations, it's a long time. So what are your question, Ray, what are the barriers that hold us back from closing on this deal?
Well, I think it's some things we talked about. In those years, technology maturity was maturing, standards were maturing.
Suppose I gave you $500 million. Could you do it?
We could do something. Yeah. So I think one of your other points in your previous session was the, putting things forth and getting judged on it, right?
You mean taking risks?
Taking a risk, right? Putting yourself out there. So
there's plenty of people who love
right. So
to take you up on that.
Right. So HECO did put forth, there was an AMI docket that was open, right? But then, issues were brought up, and then there was a question of, again, how does that then fit into the broader picture? So there were still some questions to be answered, so that docket closed and we went on for some more planning work. There also been, demand response dockets, again, questions on what's the cost, what's the benefits, are the
Right, just the
Right.
public policy
Right,
side of
right.
things.
So that
who's going to
docket
pay?
kind
all
of got
this.
closed down.
But
So
I mean,
so
isn't this really, we're all going to have to pay. And you were asking about the cost-benefit analysis. It seems to me that if I can make a state that will run on renewables, there's such a huge benefit to that. I mean, it's not only a benefit today; it's a benefit forever. And we don't know the extent of the benefit as against, oil troubles. So I don't even see an issue there. I mean, you just do it.
It gets down. The devil's in the details, right? Of what's the
devil's
solution?
in the delay.
That too. So there is a opportunity cost, right? If you don't do anything as well. So that's certainly true.
So when can we expect all this to be online?
Well, the first.
I'm talking about the smart grid,
Right,
all this,
so
stuff you've been talking about.
From the utilities plans that I've seen is the first deployment is based around a smart meter deployment, and then all using that communication system to do things like demand response, load control, conservation, voltage reduction, all those kinds of things. So that is, from my understanding, is scheduled to be deployed fully by 2018.
That's not far
It's
away.
not too far. So that's fairly near
Make
term.
a side bet or anything on that.
Not on the air, but it's again those AMI systems have been deployed on the mainland, millions of meters. So there's been a lot of vetting of the technology and maturing of the technology. So that's fairly mature. As far as technology risk goes, it's fairly low, right? So that's
Mark, could I interject with a question? When you say AMI, can you tell me where the smart meter ends and the AMI starts, and where the other end of the AMI is? I'm just trying definitionally to understand.
Okay.
This is in between your customer information system and the smart meter, the meter that's doing the measurements for you. So what is in there? Is some communications gear, and is that it?
Yep.
I mean, that's it mainly?
That's a big piece of it. So our partner Silver Springs has what they call a mesh network, but the way that works is there's a cellular communication to a access point, they call it, and from that access point it talks to the meters, and then the meters talk to other meters. So that's why it's kind of a mesh technology. But so that's part of it. So it's the meters, it's the programming of the meters, what you want it to do, it's the communications, and it's the information technology that once that information gets to the computers at the central office, vetting the data, scrubbing the data, make sure that you're getting, you're not charging somebody 10 times because a bit got flipped here or there. And then that system then communicates with your customer information system to produce the billing.
It's a big data solution, is what it is. I mean,
It's
we're doing
communications,
big
right?
data everywhere now. I
Right,
mean,
right.
we here at this table talk to so many departments in the university, and they using David Lasner. Remember him? David Lasner's new $42 million computer installation there in that building. Everybody's into big data. This is a big data thing.
Exactly. Yep. Yeah. So you can then use that information to, get information on how energy is being used on the grid. You can look at are my transformers overloaded on based on the meters that are connected to that transformer. So there's a lot of information that you can glean from that data to help you operate more efficiently, and asset management programs can be based on some of that data. But they call it AMI infrastructure, but like we talked about, it doesn't have to be just used for meters. So we're using it for the smart inverter project. We're using it for load control. It can be used for other types of monitoring.
It is really the communication part.
It enables that.
Yeah,
I guess
okay.
from a maybe a military vernacular, control,
Command
and control kind of an
Yeah,
architecture.
that's where
right?
we are.
Right. So you got a lot of things going on in the field, but you don't right now. They have no visibility or control of it.
Right.
So this kind of system helps you to get that visibility and to some extent control.
Doesn't it make you want to go to work for Mark?
I think he's got a great job.
Yeah,
And he's a senior guy.
That's right. That's
So,
right.
Ray, time for you to sum up the show. What did you learn today?
Well, I learned there's a lot going on. HNEI is really staying on top of this. These are great technologies that are being developed. We hope that you can push them to go faster because the whole world, at least the whole world here in the islands, as you know, is waiting for something that is going to help us to be able to have a more tolerant grid for whatever the customer wants to do, whether it's buy power or produce power. So it's very important, I think, for us long term to get to the clean energy future that we've been looking at.
No pressure, Mark.
But I think we need to have Mark back sometime because
Absolutely.
this
Wanna
thing is
follow
a
it with you.
developing effort. So
Yeah, it's
bring
sure.
him back in 3 months, and
Yeah.
it should be more information
Yeah,
for us.
yeah. So this and other things going on.
Yeah,
There's
thank
a
you,
lot going
Mark.
on.
Marc Matsuura, senior, junior, and middle management over there at the Smart Grid program
That's right.
at HNEI here on Hawaii, the State of Clean Energy with Ray Starling and me. We have really enjoyed this discussion.
Yeah,
Thank
me
you
too.
so much, man.
Thank you.
Tell Rick we appreciate him
I will
letting
do
you
that.
come on down, and John Cole too.
Yeah.
Aloha, you guys.
Hello.